Dear ladies and gentlemen, dear colleagues, I would like to represent the publication with topic Two-Parametric Model for Detecting Slow HTTP DDoS Attacks Based on Predicting User Behavior. And today's speaker is Vitalii Savchenko, professor of the State University of Telecommunications. Typical problems faced by any network architecture, including cloud computing, are DDoS attacks. In DDoS attacks, an attacker tries to influence the victim's server running applications from compromised computers from various locations. Slow DDoS attacks can run unnoticed for a long time due to significant similarities with the behavior of legal users with the slow connections. There are currently three types of such attacks: slow HTTP headers or slow release attacks. During an attack, the web browser sends HTTP GET requests along with the incomplete header. Slow HTTP body or Are You Dead Yet? Rooted attacks. This attack contains HTTP post requests with the full header, but the length of field contains such a large value that the server reserves all allocated resources to receive the entire message. Slow HTTP read attack. This is a type of attack where attackers send HTTP GET requests with the relevant header and the body to a web server. The core of the attack is to read the answer very slowly. There are different techniques for slow attacks detection. Some of them are based on artificial intelligence. Such approach has many advantages, although it requires a significant amount of statistics to train in neural networks. Statistical approaches are easier to apply, but their effect can be seen post factum, which requires solving the problem of forecasting. The issues of traffic forecasting for DDoS attacks detection have already been considered in our previous publications, where we proposed a single parameter forecast model based on the decomposition of a random process. In this publication, we aim to consider a two-parametric model for predicting the slow DDoS attacks based on combined usage of two parameters. Our solution is based on four-zone architecture of customer classification. All customers can be spread into four zones by their activity according to certain criteria. To recognize a slow HTTP DDoS attack on a web server, the zonal model uses two main parameters: number of connections allowed to each client and average real network latency of client availability. To solve the forecasting problem, the process under study must be represented by Formula 1. Such representation can be applied to any traffic parameter defined as a time series, Formula 2, with variance Formula 3 and correlation function, Formula 4. For detecting slow DDoS attacks, we developed the following algorithm that's based on prediction of user behavior. It allows to determine accurately the random process at control points and to provide a minimum of the mean square of the approximation error in the interval between these points. We performed the simulation of DDoS attack detection using OpenStack cloud environment with parameter fixation using Wireshark. The total number of connections was taken at 10,000 and the maximum of average real network latency 10 seconds. Figure 2 shows the initial set of the attack patterns. Predicting the attack means to determine the moment of time when the curve falls into one of critical zones as shown in figure 3. Trying to compare the particular trajectory red line in figure 4 with prediction blue line, you can see that the method gives a fairly accurate results, which depends on the time of a priori observations. Earlier, we showed that the observation time up to 90 seconds gives the deviation of prediction less than 5%. This review allows us to draw certain conclusions. First, slow HTTP DDoS attacks remain complex enough to detect minor changes in traffic parameters. Second, existing methods for detecting slow DDoS attacks based on artificial intelligence require significant statistical data for training. Method based on predicting users' behavior by the number of connections and the time of the average real network latency are more promising. Relative values of number of connections and average real network latency as forecast parameters makes it possible to build the flexible recognition system adapted to the specific particular system. The proposed method is a combination of artificial intelligence and statistical analysis and uses a self-learning algorithm with sufficient statistics of attacks. Thank you for your attention.